Deep learning has been rocked by the popularity of transformers. Transformers, which were formerly only used in natural language processing, are now also utilized in computer vision pipelines. Welcome back to Nexus Insights, your insights into artificial intelligence, tech, and software. Firstly, the general idea behind convolutional neural nets is that they go through the image, segment by segment, and extract the main features from it. The earlier layers of the CNN often extract the more crude features, such as edges and colors. However, adding more layers allows for feature extraction at a very high resolution of detail. Next, the RNNs were created to handle temporal data by taking information from prior inputs. RNNs, however, have a drawback. They cannot be parallelized because the order of the data is crucial in order to deal with sequential data. To address this problem, transformers were developed. Transformers does this job by paying attention to the input, picking out the key components, and then storing them in memory. The attention mechanism in transformers allows them to identify the parts of a sentence that are important. Attention allows transformers to filter out the noise and capture relationships between words that are even far apart. Again, what is self-attention? In this technique, each token in the sequence is compared against every other tokens to compute an attention score, which will be used to decide the output sequence, thus capturing most important information. Interestingly, we can use the same technique for images instead of using CNNs. Transformers can extract features significantly differently from CNNs by maintaining a global view of the image, thanks to the attention mechanism. Keep in mind that CNNs only find local features because they use kernels to extract features. Transformers can get around this by paying attention. Make a note that the vision transformer has encoder architecture only. This model divides the underlying image into a set of patches and then passes it into encoder along with position embedding. The output is the class of the image in the form of sequence vectors. Additionally, transformers leverage encoders and decoders. Encoders take your input and encode it into a latent space. The decoder takes vectors from the latent space and transforms them back. This can be used in a variety of ways in computer vision. We take the text input and encode it into the latent space. Then we can take a decoder that decodes the latent vectors into an image. This is how we are able to generate images from text descriptions. Although transformers have shown to be good alternatives to CNNs, their application is still somewhat difficult because of the requirement for huge data sets. In fact, CNNs can pick up new information even when there is only a limited amount of data available. Thus, it could be said that transformers are able to learn more but require more data, while convolutional neural networks achieve a lower understanding of the task addressed overall. Remember, I earlier said that transformers can be parallelized? Thus, transformers can be trained on large datasets, and that is the reason we today have large language models like GPT-4 and BARD.